Welcome to another Battlespace Simulations tutorial video. This video will provide information on how to generate and control traffic in MACE. In this video we will cover traffic generation using various methods and how it can be utilized to add realism to your MACE missions. We will begin with how to configure MACE to use OpenStreetMaps, or OSM, and demonstrate how OSM can be leveraged to build intricate routes with minimal time and effort. Once we understand how to build routes using the navigation tool, we will highlight a few options available to you to modify the behavior of your traffic. We will touch on auto throttle, lane offsets, and preventing lane changes. Next, we will cover a new feature in MACE 2019 R2, traffic signals. Traffic signals can now be added to your scenarios to manage traffic flow and increase the fidelity of pattern of life scenarios. Additionally, we will go over Easy Traffic tool to quickly generate traffic within your scenarios, along with how you can use the Mission Object Configuration tool, or MOCT, to tag certain platforms for inclusion in this feature. Finally, we will work through building an example mission that can take all these features into account. MACE includes a pathfinding algorithm for life forms and vehicles. For vehicles, pathfinding is referred to as routing and can only be utilized while connected to BSI's worldwide vector database. With this option enabled, your vehicles will navigate along the available roads to reach their destinations. To connect to BSI's worldwide vector database, navigate to the File tab, select Connect, and check BSI's worldwide road vectors option from the dropdown. Additionally, if you would like to enable residential roads, select the View tab and open the System Settings menu. Under the Communications tab, you'll find the checkbox for enabling residential level roads. Note that having this option enabled can have a noticeable performance impact in urban areas when connected to the road vector database. Utilizing the road vectors we just enabled, we will add a vehicle to the mission area and use the navigation feature to build his route. The feature is found on the Entity Control tab within the Route section. Enable navigation and use the combination of Control and right-click to select the desired destination. You can append additional destinations with subsequent Control and right-clicks on the map. Now notice that once I played the mission, he did not start moving on his route. He does not have an intent speed set, so I went to the Entity Control window and put a speed of 35 miles per hour. Now that we know how to build a route, this is a good time to cover the options available to you to further dictate the platform's actions. It's important to note that when a vehicle is following a road, the physics-based aerodynamic model is still in effect, which means that if the vehicle is traveling too fast, it can still careen off the road just as a real vehicle might. This leads us into auto-throttling option located within the Platform Properties window. To compensate for physics-based aero model mentioned previously, we have included a capability called auto-throttling. This function applies logic to vehicles that allows them to travel at realistic speeds on roads with intersections and turns. The sharper the turn, the slower the vehicle will travel to negotiate the road. If auto-throttling is not used, the ground vehicle will proceed at the set speed and likely swing wide around intersections or curved sections of the road. In this case, you would need to adjust the vehicle's leg speed around every sharp turn to compensate. Hence the inclusion of the convenient auto-throttling feature, which allows the platform to travel at its intent speed, but will also slow down the vehicle automatically as it approaches a turn and speed up again once through the turn. This feature is located in the Platform Properties window under the Navigational section. You might notice that when you use the Easy Traffic tool, the waypoints for each platform are placed in the center of the road. To prevent all the vehicles from running into each other, we've implemented a lane offset feature. This feature is found within the Platform Properties window under the Navigational section. As the tooltip indicates, the offset is the distance in feet from the center of the road. When using Easy Traffic, all of the vehicles will be given default offsets to ensure proper navigation. Lane offsets can be dynamically updated to allow traffic to move around slower moving traffic, which leads us into the next feature, preventing lane changes. MACE has logic that allows platforms to switch lanes to go around slower moving traffic. This capability adds realism and minimizes traffic buildup within your scenarios. This feature is activated by default when you add a platform to the mission. This feature can be turned off within the Platform Properties window under the Navigation section. New to 2019 R2 is the capability to add traffic lights to your mission along with the ability to control their operation using the traffic light controller. Traffic lights can be found within the mission builder under Platforms, Other. There are currently single traffic lights, T-intersection, and four-way intersections. Each type can be modified to fit your specific requirements. The colored bar that is visible from traffic lights is an indication of the current state of that signal. A bar represents a red light and no bar represents a green light. Think of this as a stopping arm that is preventing traffic from flowing past. The stopping arm will change color depending on what team the light is on. Red for enemy, green for neutral, etc. The traffic light controller can be used to configure the cycle times, light width, starting delay, and whether the light starts red. From this single window, you can easily configure all of the traffic lights in your scenario. Access by right-clicking on any traffic light and selecting Traffic Light Controls from the menu. Cycle time is the time that it takes for the signal to transition through all of its states back to its original state. Think green to red, back to green, or vice versa. Light width determines how wide the stopping arm of the signal is. This will need to be adjusted depending on the width of the road. Additional delay is the elapsed time before the signal begins its first cycle. Start red determines whether the light starts red or green. This is useful for intersections where each light is on an inverse cycle. Projected times. It's a list of times that the light will be red or green. To orient the signal in the desired direction, you can change its heading using the heading bug or by specifying a specific heading in the entity control window. This is useful for putting the blocking arm or stopping arm of that signal in the direction that you desire. Easy Traffic gives you the ability to generate a specified number of vehicles to populate your currently visible area. If you have road vectors loaded, MACE will attempt to attach the vehicles to these roads at random locations. This feature can assist you in quickly creating vehicle traffic in your MACE scenario. This capability is best used when you are connected to BSI's World Road Vector Database. This is because MACE supports automatic routing or navigation along the road network when using this database. It's even aware of one-way roads. This Easy Traffic feature is located under the Mission Builder tab. You can set the number of vehicles you'd like to add to the scenario, and the default is 20. It's important to remember that Easy Traffic will be generated in the visible extents of your mission area. Depending on your mission and what entities are available to you, you may want to cater the Easy Traffic tool to only include certain platforms. If you'd like to do this, it can be accomplished in the Mission Object Configuration tool. The MOCT can be used to specify the vehicles that appear when using the Easy Traffic tool. This can be accomplished by selecting the vehicle you'd like to modify on the Platforms tab. Under the Mission Builder section, you'll find the Include an Easy Buttons field, which can be set to either true or false. Now that you're aware of some of the features that MACE has to offer for generating and controlling traffic, I'm going to walk you through a scenario of building a simple traffic light network utilizing Easy Traffic as well as navigation for some of our entities. So as you can see here, I've already built some of our signals into the mission, but I want to walk you through the process of adding a few more of those. So the first signal we're looking at here is looks like a T intersection. So we're going to go to the mission builder. And remember, the traffic signals are under Platforms, Other. And let's drag in that T intersection. All right, so we got 3 signals in the mission area now. And I know that there's going to be a signal on this side, one over here, and then a third one over off to this side. And notice that I'm changing the heading of each of these because that dictates where the stopping arm for that signal is going to be located. And it's also good to realize that that green bar that you're seeing is not actually an indication that it's a green light. That is considered like a stopping arm. That's there to help you recognize that you cannot have traffic pass through that bar that's being positioned there. So as you can see now, I didn't lay these out properly. I've got 2 signals that are currently red, but those 2 should be in an inverse cycle. So I think this one here should be red along with this one. So let's go ahead and set this one to being a green light. So we're going to open the traffic light controls. And that's traffic light 46. Remember, if you hold control and mouse over it, you can see which traffic light that is. And we don't want him to start red. But we do, however, want traffic light 45 to start red. So let's open up that traffic window again. All right, traffic light 45, let's have you start red. So now these 2 are going to be red at the exact same time, whereas this guy will be green. So they're on an inverse cycle now. And remember that this green arm indicates how far that stopping arm is. So right now it's a little bit too long on this lane, but it may not be long enough on this side. We can actually drag this guy over a little bit more, And that lines up pretty well. But for this one, just for demonstration's sake, let's reduce his light width. Because remember that the waypoints for all of our entities are going to be along this main route here, the OSM lane. But each of our entities are going to have lane offsets, some distance away from the center of that route, if you will. So we want to stop all the vehicles that are on this side of that route. Same with this guy. We want to stop all the vehicles on that side. So now that we have those guys configured, we can recognize that we have a cycle time of 60 seconds. So that's going to be a 30 seconds of green, roughly, and then 30 seconds of red. And it'll take 1 whole minute or 60 seconds for that entire cycle to start, end, and then start again. So we understand now how to put lights in. Let's go ahead and add another vehicle or a vehicle to this mission and go ahead and give him some navigation points. So we're going to go to platforms, land, and let's just find a car. So I'm going to drag this car out while holding control down. And that's actually going to be a good indication of a new feature we have in 2019 R2. So we've given you guys the capability now under your system settings options to dictate different controls that occur when you hold the control key down when dragging something out from the mission builder. So what I have checked here is stripping the platform's waypoints whenever you hold control and drag him out. Additionally, you can set his reaction posture to do nothing or set his weapons posture to hold. I really like this because sometimes when I drag a platform out, I really don't want him to have waypoints. So that works in this case. So let's go to our entity control window and let's put him in his pathfind or routing mode. And we can do our control and right clicks to go ahead and add some destinations for him along this route. So right now we're having him navigate. And let's just go ahead and add some pretty intricate destinations for him. All right, so he's got a pretty long established route now. Now let's drag him over to his first waypoint. Okay, let's see if he's got his other features set. So auto throttle is enabled, like I said before. That will be set automatically. He has a lane offset of 7, so he's going to be 7 feet from the center of the road, offset to the right side. If you wanted to offset to the opposite side, let's say you're in a country where they drive on the other side of the road, you could give a negative offset to take into account that opposite lane. Prevent lane changes is disabled because we want him to change lanes around slower traffic and things such as that. And yeah, I think we're good to go. Let's give this guy, let's hit play, and let's give him a speed of 35 miles per hour. So we came up on our first signal here, and you notice he's got that green bar in front of him, which I was calling the stopping arm. So he cannot pass through that while that arm is in his way. It may seem counterintuitive that it's a green arm, but just realize that that arm, the color, is based on the team of the entity that you've placed. So in this case, I have a neutral traffic light, so that explains the green. If I had made it an enemy traffic light, the stopping arm would be red. So just remember that the color of the bar does not indicate what the color of the signal currently is. It's actually an indication of the stopping arm of that signal. So it would be an indication of a red light if it's out. All right, and recognize that this guy's slowing down as he's approaching his turn. That's the auto throttle that we currently have enabled, because you don't want him careening off of the road while he goes to make a turn. And that was a 90-degree turn, so it was pretty sharp. You want him to slow down quite a bit. All right, now that we've gone through adding a traffic signal as well as one entity and giving him a route, let's go ahead and try doing easy traffic to quickly generate multiple vehicles and routes. So remember, we're going to find that underneath the mission builder, and you're going to find the easy button. We're going to go to easy traffic. And remember, it's usually default to 20, but I have changed that to 35. So we're going to generate 35 vehicles. And remember, when you use this, it's based on your current visible extents. So you don't want to be zoomed in too close, because if you do that, they won't have very many routes to go along. So they're not going to have very many waypoints. So they might be doing U-turns in the road. So you're going to want to zoom out kind of far so you can have more intricate routes because you've got more roads involved. So I think this is a good extent for 35 vehicles. So let's go ahead and click that and generate that traffic. So MACE is using those OSM roads. It can use the residential roads as well as the large roads to create all the routes for those individual platforms. And you can see all 35 of them were generated. And you can see that a good portion of them have pretty significant routes. They're not just basic from here to there. They're actually making turns. They're going across various routes, and they're not all the same, which it's very useful for a pattern of life type demonstration. So now that we've placed those, let's just run through it and see how they do. So I'm going to hit play. And remember, I mentioned earlier that you can use the mission object configuration tool, and you can pick which entities you want to be in your easy traffic list. So let's say your scenario or your exercise that you're participating in dictates that you only have access to maybe a white truck and a blue sedan. You can specify in the MOCT that those are the only two vehicles that are able to be put down when you do that easy traffic tool. You can do the same with humans as well. You can dictate which ones appear in that when that tool is used. So in this case, we've got quite a few different vehicles that are being driven along their routes, and they're all taking advantage of the auto throttle. You see how this guy's slowing down as he's approaching his turn. They have lane offsets. So in some cases, one vehicle will be going faster than the other, so he might actually switch lanes to go around him. Let's see if that happens in this situation here. Well, that guy actually made a turn. Since our easy traffic scenario didn't give us a good ability to demonstrate lane changing for faster moving traffic to pass slower moving traffic, I've added two entities here that we can use to demonstrate that function or capability. So what I have is two vehicles that are going down the same road. They both have a lane offset of 7, which is the default. And I've turned off the prevent lane changes for both of these guys. It's actually off by default, so I just didn't touch it. And I'm going to set this lead vehicle to 25 miles per hour. And I'll set the tail vehicle to 35 miles per hour. And what I expect to see is once he realizes that this guy in front of him is going slower than him and that he would like to pass, he's going to adjust his offset. And it should be roughly 17 or so. So I'm going to play the mission and we'll see if he makes it his way around that other vehicle. So here we go. So there we go. He gave himself an offset of 17, made it around the slower moving traffic. Well, I hope you guys can appreciate what you've learned in this video, and maybe you guys can apply it to your own scenarios in the future. Add some of that realism and maybe a better pattern of life in some of your scenarios. Thank you very much for watching, and good luck in your future MACE endeavors.